Hello guys, and what is up? Can you guys hear me well? I think now you should hear me well. Okay, I can see myself. So, yo, how was today's contest, guys? Oh my god, I need my charger. Let me quickly be back. I'll be back soon. Okay guys, sorry. Now I have my charger. Nice. Questions were really easy. It's easy today. I solved A, B, C, D, E. I read till problem E. Problems are D. But we will solve the rest too. I mean, we will solve the rest of them too. But I mean, exactly before starting the stream, I had a work phone call and it continued till 10 minutes before starting the stream. So I had to postpone it a little bit. I hope that this was a good contest for you. Maybe we should wait a little bit more till other people join as well. Let me write it in our Telegram channel as well, that the stream has started. In discussion of round okay. Quality of today's questions were bad. Are you Iranian? Yes, I am originally from Iran. I don't think he's Iranian. No, I am Iranian. Yeah. How do I look? From where do you think I am? If you wanna judge. I mean, it's easy. Once I asked ChatGPT as well about it. Maybe today we can ask Grok about this. Do you guys know what Grok is? It's really good. It can really help me do my assignments in the university. And guys, let me say it again as well. The next video is getting ready. And it's gonna be, I'm sure that you guys are gonna like it. I'm sure about it. I had a post about it in Instagram. Let me share it in here as well. This is the topic of the next video. The next topic streams. There was several issues that caused me to again postpone the next topic stream. But I try to do it ASAP. This is the next video, especially, I had some issues. I also posted a sneak peek of the next video as well here. Nice hairstyle. Have I changed my hairstyle? Is there anything changed in it? I don't notice it. Okay, gradually more people are joining and we are getting ready to start. My rating is 1300. What should I do? Watch the videos first. I created videos exactly for you, for people with the exact same situation. Come here to the main channel of the main page of the channel, and in guideline videos you can watch this. This video has hit 48k. It's gonna hit 50k very soon. That's cool. This is the first video that hits 50k, and it's hitting there in around 1 month only. So I guess that you guys really liked this video. Okay, awesome, Siobhan. Clean it. No, it's not about cleaning, it's damaged. This is damaged, unfortunately. And it's always like this. That's the bad news. It's always like this. I can show it to you maybe someday. It's not about cleaning, it's damaged, unfortunately. Okay, shall we start talking about the problems? Are you guys ready for it? Let's go. Let's go and start talking about the problems. Okay. First off, problem A, Olympiad dates. Well, this first problem says that the final of the first Olympiad by IT Campus Neymark is scheduled for 1 March of 2025. We want to create these dates. We want to create this date, and we get digits one by one, and we have to say that when we have enough digits to write these dates. Well, basically, I say it very quickly because it's more implementation. It doesn't have much ideas. Well, the main point is that how many zeros do we need? In here, we need 3 zeros. We need 2 2s in order to make this. 3 zeros, 2 2s, 1 3, 1 5, and 1 1. These are the digits that we have. These are what we need. Okay. And whenever we have all these conditions, whenever we have enough of these, we're done. And we have enough digits to represent our numbers. So basically what we can do is to keep a CNT of size 10. It stores that how many of each digit I have. Whenever I see some digits like x, whenever I see some x, I will increase CNT of x by 1. And I can say that the first time that each time I can check if CNT of 0 was greater than or equal to 3, and then CNT of 1 was greater than or equal to 1, and then CNT of 2 was greater than or equal to 2, and then CNT of 3 greater than or equal to 1, and then CNT of 5 greater than or equal to 1, we're done. We can see out that's I, and we're done. Otherwise, at the end, if we couldn't find any answer at the end, we will just see out 0, because we could not make this number. And that's all. So basically, you should have an array CNT of size, for example, of size 10, because we have 10 digits. Whenever you got some x, you increase CNT of x by 1. And the first time that these conditions were all met, you will just output that I. And that is going to be your final answer. Is it clear? Is the solution clear? If it is clear, put a plus or use this emoji. What's up? Are you asking me? If you're asking me, good. Not bad. What's up with you? I think you participated in the Olympiad, Mr. Kaviani. I should scroll up. Yes. I was Ali Reza Kaviani's teacher. I have an interview with Ali Reza Kaviani as well in my channel. You can watch that interview here too. The interview that we had with Ali Reza Kaviani. Kavi. Hello, brother. Hello. I think it is okay. Okay, so everyone, do you want to show the codes as well? Maybe quickly we can show the code as well. It's a very simple code. You can both write it in Python or in C++, because most of you guys use C++. I show a C++ code. You can have this code. That's all. You will have F4 CNTs are initially 0, and then each time you will increase CNT of A of J by 1. If this happens, CNT of 0 was greater than or equal to 3, CNT of 1 greater than or equal to 1. You don't need these brackets as well. You can ignore them. I mean, without these brackets, it would work as well. You can just put ands between them. And CNT of 5 greater than or equal to 1, CNT of 2 greater than or equal to 2, CNT of 3 greater than or equal to 1. You're done. If at the end you didn't write anything, you will see out 0. Okay, that's all about the first problem. It was not hard. It was mainly implementation. You just had to write several conditions. How to start in CP? I can't. Well, I have also talked about how to start CP. Again, most of these things I've talked about them before. It's better if you watch the videos that I talked about. I have talked about how to start CP, especially in Codeforces. You can find them here. It's better if you watch those videos so that I don't repeat saying these things. But if you want, maybe at the end of this stream, we can talk about it again. Okay. So, no, you should practice more. It's not about learning knowledge. Again, I especially, let me pin the link here. Guys, it's more than necessary for all of you to watch all these videos here. Seriously, because I always repeat these. I have said this in videos. I also, each time in the streams, I will repeat these things. And I still believe that many people are not aware of it completely. So I strongly recommend to you to watch this. Let me also see that how it is played so that I can have some idea that what is playing. Okay, so we can talk about it at the end. Hear me out. Okay, so let's move on to problem B now. Problem B, team training. It says that at the IT campus Neymark, there are training sessions in competitive programming, both individual and team-based. N students are there, and we want to form some teams. The strength of each team must be at least X. The strength of each team must be at least X. And the strength of a team is calculated as the number of team members multiplied by the minimum skill among the team members. So for example, if a team consists of 4 members with these skills, it's going to be 4 times minimum of these values, which is 3. You have to output the maximum possible number of strong teams, given that each team must have at least 1 participant and every participant must belong to exactly 1 team. So you have several students, you want to form several teams out of them so that the strength of each team will be at least X, and the strength is the minimum value times the number of people in that team. Well, first I prove that. Let's first sort all the students by their power. Sort A plus N. I first say that it's always optimal to choose continuous intervals for teams. I'm saying that there exists an optimal answer in which each team forms a continuous interval. Okay, so I basically say that there exists a possible way such that each team forms a consecutive interval. Why do I say that? Assume that it's not like that. For example, assume that we have 2 teams. For example, one of them is the red team, one of them is the blue team. For example, red team is this one and this one, and the blue team is this one and this one. Well, I say that you can easily see that it was better if instead of this one was blue, this one was red, sorry, and this one was blue. If you change it this way, it would be definitely better. Why? Because for the red team, nothing changed. Its minimum is still the same. Its minimum is still the same. And do not forget that these are sorted, so these are in increasing order. For the red team, nothing is going to change. And for the blue team, its minimum is going to increase. So what I mean is that if you, for example, consider the first team, the team that the first member, the weakest member is in it. definitely the rest of the team members are going to be a prefix of this, are going to form a continuous part. Why? Because assume that this one is not in the team, and instead of that, this one is in the team. Definitely, you could change this to, instead of this one, add this one to the team, and nothing would change for the black team. So why using some more powerful students in there? When it's minimum, is definitely the weakest person. It doesn't matter which people are the rest of the people. So the point is size. So you will choose the weakest people to be in that team. So the team that has this weakest person is going to be a prefix. And again, if you consider the next one, if you consider the team that the next one is, again, it's going to be a prefix of the rest. Again, if you consider the next one, it's going to be a prefix of the rest. So this is the proof that in the optimal case, we can assume that each team is going to be a continuous part of the team members. What is the output needed? The output needs the number of teams. You should output the number of teams. Okay. I saw until D, but we will solve E as well, and we'll solve that too. Oh, we will solve D. I solved D very quickly. I read D very quickly, and I thought that it's trivial. I'm not sure if I read it. Maybe there's something that I missed. G, probably we solved G as well. I don't know. Let's see that how much it takes. Okay, guys, is it clear that it's continuous? If it's clear, please put the plus or use this 100 emoji. If it's not, let me know. Also, thank you for the random emojis and keeping the chat fun. Okay, so it seems like this is clear. So now I want you, I say that the next thing, the rest of it, guys, is basically a normal greedy problem. How do I work in the rest? I say that after sorting all these values, I start from the strongest person, and I will do greedily. I will move, starting from the strongest person. I will move backward, and I will continue till I find a place that this team will be strong. Its strength will be at least X. So I start from the last one. If the last one alone was a strong team, I will just put it in a team alone. If not, I will add the next person. Again, the next person, the next person, the next person. I keep adding people till I find the first time that is stronger than X. Because I know that each team is continuous, I know that the team that has the strongest person is gonna contain a suffix of people, right? It's gonna contain a suffix of people. So I keep adding them, and I will consider the first time that is greater or equal to X. And then I increase my answer by 1, and then I start all over again next time. Again, I will add people till it gets greater or equal to X. The first time that it got greater than or equal to X, I will again increase the answer and start all over from the beginning. So for example, if you take a look at this first example, is 6, 4, let me write it here and then we will move back to tablet. 6, 4, 4, 5, 3, 3, 2, 6. What I do is this. First I sort these values. After sorting them, it will be like 2, 3, 3, 4, 5, 6. This is the sorted one. And I prove that in the final answer, each of the teams will be a continuous part. Now I start from the end, and I will, each time when I have a team that is strong enough, I will set that as a team and start all over from the beginning. Otherwise, I will continue adding people to the team. First, I see that this is a person with a strength 6. I say that this one, this person alone makes a good team, makes a strong team. So this is going to be my first team. Then I start from the beginning. I have this person with strength 5. Again, I see that this person alone is a strong team. So this person will also be a team by himself. And again, starting from this one has a strength 4. So alone, again, I see that it has enough strength. It's greater than or equal to X. So this person will also be in a team alone. Then I'll come to this person. This person alone does not make a strong team. So I should add more people. So I add the next person, and now the power of this team is 3 times 2, which is 6. So now it's strong. So this is gonna be my next team. This is gonna be my 4th team. And then I come here, this person is 2, and it's not strong enough yet. I have to add more people, but I ran out of people. So this team cannot get fixed. There's no way that this last team gets fixed. So my answer is gonna be 4. With this greedy algorithm. And if you take a look at the answer, you see that it's really 4. So basically we sort all the people, start from the end, greedily add people. Whenever we construct the team was good, its strength was X, at least X, we say that okay, that's a good team, just separate them from the rest, and now solve the problem in the rest of the people. Again, start this greedy from the beginning and construct the next team. So this is the algorithm that we have. So we have a sort which is O of n log n, and at the end it's just an O of n iteration. And just keeping track of the minimum is exactly the one that we're at, because we're going one by one in the decreasing order. We are starting from the strongest one and going to the weakest people. So the minimum is the current one, and you can also keep track of the size. So you can easily find out what is the strength of the current team. So this way you can just simply find the answer. If it's clear, please put a plus or use this 100 emoji again. I'll quickly show you the code as well. Okay, I'll show you this code that you suggested. Awesome. I use priority queue in this. Maybe you can do that, but it's not that necessary. I mean, it can be solved simpler. Why do we start from the strongest one? Can we not start from weakest one instead and select until greater or equal to X? Okay, that was a good question. Why am I starting from the strongest one? Why am I not starting from the weakest one? Understood why it's not bad to be continuous, but didn't get why it's the best. I will talk about this as well. Let me first talk about this, because this is an earlier thing. I said that it's not bad for them to be continuous. So when it's not bad for them to be continuous, I can say that there exists an optimal answer such that they are all continuous. Maybe there exists also some optimal answer that they are not continuous. But also, I'm sure that there exists some optimal answer that they are continuous. So if I assume that, okay, now I'm also forced that they will be continuous, do you agree that the answer will not change? Because if currently the answer is X, if I change the condition to that each of these teams must form a continuous subsegment, you saw that it's not getting worse. So still I can achieve the same answer. So I'm adding an additional requirement to the answer by myself that will simplify the problem. And I'm sure that by adding this additional requirement, still the answer is the same. Is it clear? Fahmid? Or Fahmid? So yes, it will still give us the same value. Okay, and also another question. You said it said that every participant must belong to exactly one team. You're welcome. To exactly one team. Yes. Right now, again, each person belongs to one team as well. The only point is that this last person is not in a strong team. This person belongs to a team, but each person must belong to a team, but not necessarily a strong team. So this last person belongs to a team, but it's not a strong team. Okay, you're not forced to have all of them in strong teams. For example, in the second case, you can create 0 strong teams, but you can make it, all of them can be in a team, but that team will be weak. So we have 0 strong teams. So that doesn't contradict that. This last person still is in a team, but this person is in a weak team. And why did I start from the last one? Why didn't I start from the first one? Well, because as you said in this example, the first person might be in a weak team. We are not sure that the first person really is gonna be in a strong team. Okay, so the point is that we are not sure about the first person if he or she is gonna be in a strong team. But for the last person, because it's gonna be a suffix and this person is the strongest person, if there is any strong team, this person can be in that. I mean, basically, I'm saying that if there is any way that I have a strong team, there also exists a way that this strongest person, is gonna be in that. Or in other words, this strong team is gonna be a suffix. So the difference between the first person and the last person, and why did we start from the last person, was that the last person can be in a strong team. The first person might not be in a strong team. And even trying to put him or her in a strong team might ruin everything. But for the last person, we know that if there is a way to create a strong team, there also exists a way that this last person is going to be in that team as well. There's a way that this is going to be at the last team, because this person is the strongest one. This one has the most priority to be in a strong team. So if there is a way to make a strong team, this person is going to be in that. So that's why we start from the last one, because just consider the last strong team you have, you can add this part to it as well, and still it would be strong. So there exists an optimal answer if there is a way that again it's like what we said previously. There also exists an optimal answer such that except the first interval, the rest of the intervals are strong. We are going very deeply into the theory part to formally prove everything. So basically we're proving that okay, every interval except the first one are gonna be strong. The first one might be strong, might be weak. Okay, is it completely clear? Awesome. Okay, I will show the submission. Some people have wrote it in Python. Let me show this Python code as well, and also the submission that you guys suggested. This is in Java. So yeah, basically what he does is this. He sorts the elements and start from the end, and the first time that it was greater than minimum strength, you will add answer by 1 and start from the beginning. Otherwise, you will keep going till you will find some index that eventually it gets strong, and then you will continue from there. So that's basically the idea that we discussed. Let's see this Python code as well. This one looks very short and interesting. Let me see what has he done. Well, a length was equal to 1 f a dot pop. So he again got a and sorted a, and he will keep doing this while the length of a was not 0. He starts from the end, and he says that if len, basically this is again the same idea. He says that if a dot pop is the last element that is in a, still is in a. It's the last element and then removes that last element from a. While this times len was greater or equal to x, ans will be added by 1. If that happens. Otherwise, again, we pop the next one. So we will keep popping from the end. The first time that they made a strong team, we're good. And that's going to be our answer. Let me show a C++ code very quickly as well, because most of you code with C++. C in n and x, C in aj's, find ans. We have a sort start from the end. The first time that this is greater or equal to x rest plus plus, c equal to 0. Again, the same thing. Start from the end. The first time that it was at least x, we will add 1 to ans and CNT will get 0. Okay, yeah, the Python code is very nice and clean. Yeah, each time I try to show one of the codes, so maybe you can suggest your codes for the next problem. Brother, do you need help? Okay, let me know if you ask anything. Abhishek. Okay, if it's clear, let me know so that we will move on to problem C now. I answered your question, BTD. I strongly recommended you to come and watch these videos, these guideline videos, and because you're just starting, you should also watch the videos in this section as well about competitive programming. I want to be like you want to be like me? Why? How can 8K submissions for E? I find it's good problem to figure out the solution. Yeah. Well, at some point I friended him. I just added him as friend. Yes. Sure. Okay, so now let's move on to problem C. I will talk about constructive. I think I already have a topic stream about constructive problems. I think we recently had it, didn't we? Maybe it's not here. Guys, the ones of you who always attend the topic streams, didn't we discuss constructive very recently? Okay, maybe we didn't. So we can discuss it in the next topic stream. Problem C. Write your submission when I was showing the code, and I will choose one randomly, so there's no logic in it. I just choose one randomly, not necessarily the first. I see the first one that catches my eye, so don't feel like it's unfair. It's just I want it to be quick. So the next problem C, combination lock. At the IT campus Neymark, there are several top secret rooms where problems for major programming competitors are developed. Basically, it says that we have a permutation of numbers from 1 to n. We want to have a permutation from 1 to n such that each cyclic shift of it will have exactly one fixed point. What does it mean? It means that each cyclic shift of it should have exactly one I, such that A sub I is equal to I. Okay, so each cyclic shift must have exactly one I, such that A sub I is equal to I. For example, if you take a look at this permutation, 1, 2, 3, 4, 5, 3 is a fixed point. It's at the third position. If we shift it, sorry, not 1. Why I said 1, 2, 3, 4, 5. 4, 1, 3, 5, 2. This has exactly one fixed point, which is 3. And if we shift it once, it's gonna be 2, 4. You know, the 2 comes here to the beginning and everything shifts forward. It's gonna be 2, 4, 1, 3, 5. Again, if we shift, we see that 5 is a fixed point. Again, if we shift it, 2 is gonna be here. And again, if we shift it, 4 is gonna be here, and again, if we shift it, 1 is gonna be here. So basically, you have to, for given n, you have to give a permutation such that each cyclic shift of it will have exactly one fixed point, exactly one I, such that ai is equal to I. Okay, so how does this work? Yeah, I want to fully prove everything. Guys, basically what we have, I mean, let's consider AI. AI is in position I. I mean, in position I, we have number AI. right? Let's write position above the number. This is position I. It has AI. Position 1 has A1, position 2 has A2, position 3 has A3, and so on. How many cyclic shifts do we need to the right? I mean, how many times we should shift it to right such that AI goes to its correct position? So I'm asking that how many times should we shift AI to right such that AI will go in its correct position? Can you give me any formula? So again, for example, let's give an example. For example, if you see A of 2, it's 1. You must shift this permutation to the right 4 times such that 1 comes to its correct position, which is 1. If you shift it 4 times, 1 is going to go to its correct position. So how many times should I shift AI forward such that it goes... It's not ABS of AI minus 1, minus I. Because I'm talking about shifting rightward. If I was both considering shifting leftward and rightward, it was correct. Yeah, you're close, but it's not still correct. It's just not ABS of AI minus AI. I'm saying that how many times should I shift it rightward such that AI goes to position I? No, AI. So it must be related to AI. No, for example, let's take a look at this. For example, for this 1, for this 4, how many times should I shift it forward? For this 4, I have to shift it forward 3 times. I have to shift it forward 3 times so that it goes to its correct position. For this 1, I have to shift it forward 4 times so that it goes to its correct position. For this 3, I have to shift it forward 0 times. It's in its correct position already. For this one, we have to shift it forward once so that this one goes to its correct position. And for this one, we have to shift it forward twice so that it goes to its correct position for this 2. So basically it's gonna be like this. So what is the formula exactly for some AI? No, it's not 1. AI minus I is good. But what if it was negative? Very close. Okay, let me tell you this. The number of times that you have to shift it forward is gonna be AI minus I modulo n. In order to, I mean, when I say modulo n, I'm talking about the positive value of modulo n. But for example, if you write it in C++, if you want to make sure that it's going to be positive, you have to add an additional n as well. So it's going to be AI minus n plus AI minus I plus n modulo n. Why? Because this is position I, this is position AI. I should see that what is this distance, and it's gonna be that value. But also it's possible that AI is before I, in which case I should go till the end and cycle back and come here. So it's gonna be AI minus I, and I should consider it modulo n. In C++, in order to make sure that that's gonna be positive, I have to add an additional n to it as well and then take modulo n. Okay, why not ABS of AI minus I? Because ABS of AI minus I, as I said, was if I could shift leftward as well. I'm talking shifting rightward. You will see that's why I'm just considering shifting rightward. For example, in here, if it was ABS, this one would be 1 because I can just shift it leftward once. But what I'm saying is that how many times I should shift it rightward. I'm just considering the rightward shifts. Okay, is it clear? Sorry, I didn't show it to you. I said that in here, if it was ABS, this one would be 1 because I could just shift it leftward once. But I'm just considering shifting rightward, and I will tell you that's why I'm considering this. I will tell you that's why I don't consider both shifting rightward and leftward. Is it clear so far? If it is, please put a plus or use this emoji. If so far it's clear. Guys, right now we're not moving on the submissions. There's still a lot on the answers remained. Okay, so now why did I... Okay, one more time. I said that, well, for each I, if you consider AI, how many times I should shift it forward such that AI goes to its correct position? I say that the number of times that I should shift forward is gonna be AI minus I plus n modulo n. Okay, so I'm saying that because it's cyclic shift, if AI is just 1 after I, it's gonna be 1. If it's gonna be 2 positions after I, it's gonna be 2. If it's gonna be 3 positions after I, it's gonna be 3, and so on. I should see that how many times I should shift it forward such that AI goes to the position AI. So it's gonna be AI minus I modulo n basically. Okay, it's gonna be AI minus I modulo n. Okay, and I'm talking mathematically, not in C++. In mathematically, when we say modulo n, we mean positive numbers. For example, minus 2 modulo 5 is 3, basically. In C++, if you write that, that's not right. I mean, that doesn't give you that. But in mathematics, when we say minus 2 modulo 5 is 3. So basically, it's going to be AI minus I. It's going to be AI minus I modulo n. So in other words, if it was negative, just add an additional n to it. Okay. I want to talk about the full details. That's why I'm starting from here. Okay. But yes, I don't want to just spit out the solution. I want to go through the thinking process and reach the final answer. So we need these many shifts forward if we want to do that. And why is that important? The reason is if you take a look at it, if each time we want to have one fixed point, these numbers must be different. So this means that if I don't shift forward, this one would work. If I don't shift. If I shift once, this one would be a fixed point. If I shift twice, this one will be a fixed point. If I shift 3 times, this one will be a fixed point. And if I shift 4 times, this one will be a fixed point. So basically, these numbers must be different. The number of shifts that each one of these need must be different to each other. This way I'm sure that by shifting it, each time one of them will be in their correct position. So basically what I mean is that these numbers must again be a permutation from 0 to n minus 1. So basically if you consider these values, ai minus I modulo n's, these values of ai minus I modulo n, these numbers must create numbers from 0 to n minus 1, a permutation of 0 to n minus 1. That's the main thing. There should be a permutation of 0 to n minus 1. And why is that important? Why is this thing important? Okay, I want to first prove that it's not possible. It's not possible if n is even. If n is even. I'm talking about the whole thinking process. So when I looked at this problem, the first thing that I was thinking was that, okay, the number of shifts that each one of these needs must be different to each other. The number of shifts that AI needs is AI minus I modulo n, right? The number of shifts that AI needs is AI minus I modulo n. All these numbers must be different. So all these AI minus I's must be different. But if you sum them up, if you sum up these AI minus I modulo n's, On one hand, it should be the sum of 0 to n minus 1, because I said that I want it to be a permutation. If it is a permutation of 0 to n minus 1, this value must be modulo n. It must be equal to 0 to n minus 1, the sum of 0 to n minus 1. But on the other hand, this number is also 0. Because these i's are numbers from, this sigma of ai minus I modulo n is sigma of ai's minus sigma of i's, and the whole thing modulo n. So if I talk a bit anything, if I want to see that to which number this is congruent, this is congruent to 0. Because in ai's, each number from 1 to n appeared once. In i's, each number from 1 to n appeared once too. So if I sum up ai minus I modulo n's, it's going to be 0. So the whole point is that the sum of 1 to n minus 1 modulo n must be 0. In other words, the sum of 1 to n minus 1 must be divisible by n. If it's not, there's no way. If the sum of 0 to n minus 1 is not divisible by n, there's no way to do it. Is it clear what I'm saying? Again, if it's clear, please put a plus or use the emoji. Use the 100 emoji if it's clear. So I kept that how many shifts do I need for each element to be in its correct position. I said that one of them should be 0, one of them should be 1, one of them should be 2, and one of them should be n minus 1. So the sum of these numbers on one hand must be 0 to n minus 1 modulo n. On the other hand, this number should be congruent to 0 modulo n. I haven't yet said that y even is not possible. So far I'm saying that the sum of 0 to n minus 1 should be divisible by n. And what is the sum of 0 to n minus 1, if this part is clear? Yeah, sure. I say it quickly one more time. I'm saying that for each number, I want to see that how many times should I shift it so that it will go to its correct position. I say that one of them should be 0, one of them should be 1, one of them should be 2, one of them should be 3, and so on. One of them should be n minus 1. So if I sum up these values, these ai minus I modulo n's, they must be congruent, modulo n, they must be congruent to the sum of 0 to n minus 1. On the other hand, they must be congruent to 0. On the other hand, they must be congruent to 0 because this sum is basically 0. Okay, so basically I'm considering modulo n. Because I'm considering modulo n, you can even forget about these things because everything is considered modulo n. Sigma of ai minus I is 0. On the other hand, it must be congruent to sum of 0 to n minus 1. So sum of 0 to n minus 1 must be divisible by n, which is n minus 1 times a n half. So the question is that when, and this is a very famous thing in mathematics, so be focused on these parts to completely comprehend. When n minus 1 times n half is divisible by n. The point is that if your n is odd, n minus 1 n half, n minus 1 times n half, if n is odd, is gonna be n times n minus 1 half, which is an integer, so it's gonna be divisible by n. But if n is even, n times n minus 1 half is gonna be n half times n minus 1, which is n half is an integer, n minus 1 is an odd number. This number is not divisible by n. Indeed, this number modulo n is n half. This number is not divisible by n. Because these two will cancel one of the 2's of n if n is even. And therefore, it's not going to be divisible by n anymore. But if n is odd, this will cancel one of the 2's of n minus 1. So still the number will be divisible by n. So, okay, I will repeat it. So basically, I'm saying that if n, this is a very famous thing in mathematics, n minus 1 times n divided by 2, or in other words, the sum of 0 to n minus 1. Also, you could say the sum of 1 to n. This sum is divisible by n if n is odd, and it's not divisible by n if n is even. Why? Because n minus 1 times n half, if n is odd, is gonna be n times n minus 1 half. So it's a multiple of n. So it's divisible by n. Because these 2 will cancel one of the 2's of n minus 1, it will not harm n. So it's still divisible by n. But if n is even, these 2 will cancel one of the 2's of n. So it will harm n. And the number is not divisible by n anymore. So because n minus 1 is also odd, so when you divide it by 2, you will lose one of your 2's, while n has that 2. So this number cannot be divisible by n anymore. That's why it only works when n is odd, and we prove that this way. We prove that if n is even, it's not possible. It's not possible. Is it clear? If it's clear, please again put a plus or do this emoji. It's really a nice thing to have. Oh, to have in mind. Okay. How often you have a haircut, Cheyenne? Why do you guys feel like I have a haircut? I had the same haircut last time. Has my hair changed really from the last time? Sorry guys that I'm getting distracted, but you distract me. This is my last stream that I had 3 days ago. Has my hair changed? I often maybe I have haircuts once every month, 3 weeks to month. Haircut in here is very expensive in the US. So wherever you are, tell me that how much haircut costs in your country in dollars. Your hair doesn't grow, dude. It's only 3 days. What do you expect? What do you expect in 3 days? $10, $0.3, $8, $0.8, $5, $1, $0.5, $0.4, half a dollar, $1 to $2. That's very good. And how much do you think it costs here in the US? I will get back to this proof. Yeah, I will say that. $50. You guys are very good in guessing. Yes, it's around $50. It's from $40 to $60, somewhere between 40 to 60 in different places. Maybe some places can be a bit cheaper, like 35 or something. Maybe some places can be very expensive. There definitely are places that are more expensive, like maybe even 100, 200. But yeah, in average it's around $50. Yeah. Okay, let's get back to the rest of the solution. Why are we calculating sum? Guys, basically, I calculated sum. Why did I calculate the sum? I calculated the sum to show that it's not possible that n is even. Why? Because I said that, okay, assume n is even. And we did it. I want to prove it by contradiction. Assume that n is even, and we did it. Let's calculate sigma of ai minus I modulo n. In one way, we know that if this is true, it must be the sum of 0 to n minus 1. But in another way, we also know that this number must be 0. because each number appears once in I and in AI. So if n is even and we have done it, I'm proving my contradiction. I assume that okay, we've done it. Then sigma of ai minus I must be equal to the sum of 0 to n minus 1. On the other hand, it must be 0. But I want to show you that if n is even, it's not possible that this number, which is equal to n minus 1 times n half, it's not possible that this number is divisible by n. It's not possible that this number is divisible by n. Why? Because if n is even, this 2 will cancel one of the 2's of n. And n minus 1 is also odd. It cannot contribute any 2's to make up for that. So we will lose one of our 2's. We will lose one of the 2's of n. So this number will not be divisible by n anymore. So this will not happen. So this is a contradiction. These two numbers are equal while they cannot be equal. So why did I calculate the sum? To show that it's not possible if n is even. Is it clear now or not yet? So a barber earns more than $10,000 per month? I don't think so. Taxes are high as well, but I don't know how many people they do per day. I don't know how many people go there for each of the barbers. Okay, so the case when n is there, the cost of living is very high. Good. So if n is even, it's not possible. Now I want to show that if n is odd, it is possible. I construct a way. So now assume that n is odd. I want to show you that if n is odd, there is a way. Is a way. Why there is a way if n is odd? I construct it. Let's construct. How do I construct it? I say that let's put the middle number. I mean, let's put the middle number correct. Assume that, for example, let me construct it by an example. Let's say that n is 9. If n is 9, the middle number is going to be 5. 5 is going to be the middle number because there are 4 numbers before it, 1, 2, 3, 4, and 4 numbers after it, 6, 7, 8, 9. So the middle number is n plus 1 half. In here it's going to be 5. Let's put 5 in its correct position, at position 5. And then I'm again talking about the thinking process. At the end, I can say it in an easier way, but this was the way that I was thinking. At the end, we show that it is equal to something else. And then swap 1 and n. So put 9 here and 1 here. This way, 9 needs 8 cyclic shifts to get to 9, and 1 needs 1 cyclic shift. And then swap the next two numbers as well. Put 8 here and put 2 here. Then 8 needs 6 cyclic shifts and 2 needs 3 cyclic shifts to get to 2. And for 5 it's 0. And then put 7 here and 3 here. Then 7 is gonna need to have 4 cyclic shifts. 3 is gonna need to have 5 cyclic shifts. And then put 6 here and 4 here. 6 is gonna need 2 cyclic shifts. 4 is going to need 7 cyclic shifts. So if you take a look at it basically this way, in here you can start from n minus 1. The first one is gonna need n minus 1 shifts, and it will keep decreasing by 2. n minus 1, n minus 3, n minus 5. And in here, this one is gonna need 1 cyclic shift, and it will keep increasing by 2, 3, 5, so on. And this way, because n minus 1, n was odd, so n minus 1 is even. So basically these numbers will be all the even numbers that we need, and these numbers will be all the odd numbers that we need. And this way we really construct the permutation from 0 to n minus 1. Each of these is going to be need a different number of shifts to go to its correct position. So, and what is this? Basically it means that we have reversed the array. So I'm saying that basically let's reverse the array. When we reverse the array, if you take a look at it, when we reverse the array, we write n minus 1, n minus 2, and this one is n minus 1, n plus 1 half, and go to 3, 2, 1. If we consider this, you can see that this one needs 0 shifts, this one needs 1 shift, this one needs n minus 1 shift, this one needs n minus 3 shifts, this one needs n minus 5 shifts, this one needs 3 shifts, this one needs 5 shifts. So we have 0 here, we have odd numbers here, and we have even numbers here. So all the numbers appears once. If you shift once, this one will be in correct position. If you shift if you don't shift, this one is going to be in the correct position. If you shift once, this one will be in the correct position. If you shift twice, this number will be in the correct position. If you shift 3 times, this one will be in the correct position. If you shift 4 times, this one will be in the correct position, and so on. So basically, the code is very simple. The theory was hard. The code is very simple. I say that if n is even, there's no way. If n is odd, just reverse the array. Reverse the permutation, write n minus 1, n minus 2 to 1. That's all. So all this hassle, all the things that I said was about the theory part and the thinking process that reaches this solution. But the final solution is this. If n was even, there's no answer. If n was odd, just write the reverse array. If it's clear, please put a plus or use this emoji. Yes, you can get the idea about pattern recognition as well. Maybe test the first numbers and see if that's, and maybe after that guess the proof and guess the solution and prove by AC. You can prove by AC, but we want to learn something here. So that's why I explained. Yeah, in a contest, if you really had great intuition that yeah, this should work, you can code it and get accept from the problem. But definitely after that, try to find out that what was the reason as well, so that you can learn something from it. Okay guys, because you sent a lot of submissions, I feel a bit pressure to choose one, but I really chose one. This one took my eye. I mean, came in front of me. So I show it to you. Sorry to anyone that I couldn't choose their answer, but maybe in the next problems. Let's see what. Okay. Yes, so basically he did this. I mean, that's very simple. He just seen t, he just says seen t, and then for each case, if n modulo 2 was 0, see out minus 1, otherwise see out everything in reverse order. That's all. So he will, if n modulo 2 was 0, he will see out minus 1. Otherwise, he will go backward and see out numbers 1 by 1. And that's all. So you see that all these things that we say was theory, but the code is just this. The code doesn't need anything else. You just say that if n was even, just see out minus 1. If n was odd, just write them backwards. Okay. If it's clear, again, put the plus and use this emoji, and then, yeah, we will move to D. Yes, sir. We will move to D ASAP. All the odd ones first, yeah. All the odd ones first in increasing order. That's also works, because if you put all the odd ones first, you are creating, the first one needs 0, the second one needs 1, the third one needs 2, and so on. So the first half creates 0 to n half, and then after that, when you put even ones, you create the bigger numbers. Yeah, you also, if in that case, right, that's how many cyclic shifts you need, You start with 0, 1, 2, 3, 4, 5, and so on. And then after that, you're gonna have the greater numbers, the rest of the numbers. But this time backward. Oh, no. It's still straight. Yeah, that should work as well. Okay, I'll talk about D as well. I skimmed through D. I didn't read it completely. I mean, I think I read it completely. I hope that I didn't lose anything, any detail in problem D. Okay, let's move on to it. Problem D. Place of the Olympiad. And guys, by the way, if you like the video and you are enjoying this, you can subscribe to the channel. That would support me, and also you can attend the rest of the topic streams and solution discussions as well if you want it and you're learning something from it. I would love it if we have more and more people each time. Right, so now after 1 hour, still more than 110 people are here, and that's awesome. I try to have the topic. I don't want to promise again because it's gonna be so bad if I again promise something and I don't do that. But I try to have the topic stream as soon as possible. You guys, if you want to be alert of when the topic stream is gonna happen, you can join the Telegram channel to be aware of that. Let me pin this one now. Okay, let's talk about problem D. Problem D, place of the Olympiad. It says that for the final of the first Olympiad by IT campus, a rectangular venue was prepared. You may assume that the venue is divided into n rows, each containing m spots for participants' desks. A total of k participants have registered for the final, and each participant will sit at an individual desk. Now the organizing committee must choose the locations for the desks in the venue. So we have this n by m table. We want to choose some locations for the desks. Each desk occupies one of the m spots in a row. Moreover, if several desks occupy consecutive spots in the same row, we call such a group of desks a bench. And the number of desks in the group is the bench length. For example, in this example, we have one bench of length 3 in the first row. And in the second row, one bench of length 2. In the third row, we have two benches of length 1. The organizing committee want to choose the locations so that the length of the longest bench is as small as possible. In particular, same 7 desks can be arranged in a more optimal way this way, such that the longest bench is gonna have length 2. Given the integers n, m, and k, determine the minimum possible length of the longest bench. Guys, after reading this, I felt like it can be solved with a simple math. How? Well, basically, again, let's consider the cells that they do not have bench. Instead of k, let's consider nm minus k. Guys, the best case is to distribute these evenly in different rows because we want to minimize the maximum. So the maximum row is important for us. When we want to minimize the maximum row, it's better to distribute them. I mean, because if, for example, a row has more desks, it's possible that it's gonna have a longer bench. So it's better to balance them in different rows. Because we don't care about sum or anything, we care about the maximum. We want to decrease it as much as possible. So it's better if we distribute them evenly. So if, for example, we have L rows, L is nm minus k, such that they are gonna be empty, it's best to distribute them evenly. And in the worst row, we're gonna have the floor of L over n empty rows. So we know that how many empty rows do we have in our worst row. And then now the question is to how to arrange these empty cells in that row. Okay, do you agree with it so far? So it's just about the fact that we can just distribute these desks in different rows. If you agree, please put the plus or use the emoji, or if you believe anything is not right, let me know. I'm a bit hesitated because the solution that is in my mind is very easy. It's even simpler than problem C. So that's why I'm wondering. Max people in a row is k plus n minus 1 divided by n. Yes. That's also right. It's the sailing of k over n. Can you repeat? I was lost in my thoughts. Okay. I'm saying that, guys, the best case, I mean, if we have some desks, it's the best to distribute these desks in different rows evenly. I mean, as much as we can, we distribute equal number of desks in different rows. So as much as we can, the idea is that as much as we could, we will distribute these desks equally in different rows. So basically, each row will have around k over n desks, either sailing of k over n or floor of n over n. Okay, the worst row has sailing of k over n rows, desks. And in other words, if I consider the empty cells, L is going to be the number of empty cells. It's going to be n times m minus k. The worst row is going to be the floor of, is going to have the floor of L over n empty cells. So that's what I'm saying basically. I'm saying that, okay, we'll distribute them evenly. The idea that is in my mind doesn't even use binary search. It's just mathematics. Is it clear? No, I mean a disk, because it's defined as disk. These green cells. Participants' desks. These green cells. A bench is some set of consecutive green cells. A desk is one of these green cells. Is it clear now or not? I see. Yeah, if any part was not clear, you can let me know. So basically, I'm saying that we will distribute them evenly. If you agree with that, please put the plus or use the emoji. Yeah, I also think that with using only math, it would be okay. Okay, so if there's no objection on this, I will continue. So now we know about our worst row. We know that how many empty cells does it have and how many desks does it have, how many green cells does it have. Now, again, what is the best way to distribute these M cells? I want to put these bad cells, again, let's call the number of cells that are empty B. B is the number of cells which are empty. I say that it's the best to distribute them in a way that these blocks, the maximum of them have the minimum length. That's basically what we want. We want the maximum of these to have the minimum length. So how can we do that? Again, we have to make these parts as equal as possible. Okay, we want to again make these parts as equal as possible. This row has M cells. M minus B of them are gonna have desks, are gonna get green. And I have B empty cells. These B empty cells can separate B plus 1 blocks. So it's like if I put them in different places, I can create up to B plus 1 different blocks. So basically, I will have M minus B over B plus 1. My maximum is gonna be the sailing of this value, M minus B over B plus 1. Why? Because I have B batch cells. Maximum of this and 1. Maximum of this and 1 if we have at least one desk, at least one green cell. I say that, okay, there are M cells in total. B of them are empty. Those empty cells can just separate B plus 1 different blocks. The best thing is to distribute these green cells into equal sizes. If I distributed them into equal sizes, there are m minus b green cells, b plus 1 blocks. So I distribute them equally. It's going to be m minus b over b plus 1. So the worst one is going to be the scaling of this value, the scaling of m minus b over b plus 1. Why scale? Because I'm talking about the maximum. When I'm distributing them into b plus 1 blocks, some of them are going to have floor of m minus b over b minus 1. Some of them are going to have the scaling of m minus b over b plus 1. I'm talking about the maximum. So the maximum is going to be the scaling. It's very similar to the pigeonhole principle. There are m minus b pigeons going to b plus 1 pigeonholes. Definitely one pigeonhole will have at least the scaling of m minus b over b plus 1 pigeons. So that's the reason. We don't even need maximum with 1 as well, because we use scaling. For example, let's say that we have, let's say, 7 cells. Yeah, let's have 7 cells like this. We have 7 cells and B is 2. I say that I can put these 2 cells in a way that, for example, I can put them like here and, for example, here, in a way that they will break it into 3 parts. They will break the good cells, the green cells, the desk cells into 3 parts. And how many green cells do I have? M minus b. M minus b is 5. This way, if I break them evenly, separate them evenly with almost equal sizes, the longest one is going to have the length of 5 over b plus 1, 3. The scaling of this value, which is 2. So the least value that I can get is 2. So the main point is this. The best way is to somehow distribute these values evenly. Okay. Is it clear or not? If it's clear, again, put a plus or use the emoji. I did not get it. I will repeat it. No worries. But the rest of you, if you understood, please put a plus or use the emoji. I want to have some statistics to know that how many of you understood it. You can use the emojis as well if you want. I start filling the even columns followed by even columns. Too much math. Yeah, but it's not that complicated. I mean, guys, the main point is that assume that I have several bags. Okay. Assume that I have several. Let's say this. Assume that I have several tasks. I have 7 tasks to do. I have 7 tasks or 7 assignments to do. 7 assignments to do. And I have 3 days to do them. I want to do it in a way that in none of the days I get so tired. So I want to distribute them in a way that in each day, I mean, the worst day that I have will be the best. I want to distribute them such that I want my worst day to not be that, but I don't want to get that tired in any day. So I do not want to do a lot of assignments in the same day. What is the minimum number of tasks or assignments that I have to do in at least one of the days? If I want to minimize the number of tasks that I do in one of my days, at least, what is the minimum value that I can get? Yeah, once you understand it, it's gonna be basic math. So I have 7 assignments to do. I want to do them in 3 days. I want to do it in a way that I won't get under pressure so much in a single day. Exactly, I have to do 3 of them on the same day, at least. Because there are 7. If I do only 2 of them each day, I can do only 6 assignments at most. But I want to do 7 assignments. So I need to do 3 of the assignments at least in one day. So it's going to be the sailing of 7 over 3. Okay, I have to do, or in other words, let's say that I have 7 pigeons. They want to go to 3 pigeonholes. And I don't want any pigeonhole to be that crowded. But what is a lower bound that I can give? That for sure one of the pigeonholes will have at least these many pigeons. I want to minimize, I don't want, because if there are so many pigeons in the same pigeonhole, they will fight with each other. So I do not want to have too many pigeons in the same pigeonhole. How can I distribute them to have the minimum, to make the maximum number of pigeonholes in a pigeons in a pigeonhole minimized? What is it gonna be? What if you have more days than assignments? 7 days and 3 assignments. In that case, you will have, at worst case, it's gonna be 1. And the sailing of 3 over 7 is also 1. It's the sailing of 3 over 1. 3 over 7. 3 over 7 is point something. Its floor is 0, its sailing is 1. Its sail is 1. In a row, we are basically taking blocks of size. Yeah. So basically, if we have 7 pigeons, they want to go to 3 pigeonholes. At least to one of the pigeonholes, 3 pigeons will go there. At least, let me draw a great shape for you. I don't know how to write pigeons, but something like this. At least to one of them, there will go at least 3 of these pigeons. I mean, anyway, definitely I will have at least 1 of them. Like this. Right? There's no way that I will not have any pigeonhole with 3 pigeons. I will definitely have 3 pigeons in at least one of these pigeonholes. So, getting back to this, I have m minus b. I have m minus b green cells. M minus b green cells. And I know that I can break them into b plus 1 blocks. I can break them into b plus 1 blocks. I have b block cells. They can separate them. They can separate these into b plus 1 blocks. So because of that, I want to distribute them evenly as much as possible. So I want to make the sizes of these blocks, these bands, as close as possible. So each one of them will have around m minus b over b plus 1. The size is going to be m minus b over b plus 1. But this number might be fractional, might not be an integer. But our answer is an integer. So what should we do? We get the sailing of it. So that's all we do. So basically what I say is that first I define L as the number of empty cells that I have. It's going to be n times m minus k. And then I say that the number of empty cells in the worst row is going to be L over n. Because I have n rows. Let me write it mathematically. Because I have n rows. And in one of them, I have at most L over n empty cells. So it's going to be floor of L over n. Because I want to distribute them evenly, in the worst one I will have L over n empty cells. And then I say that these B cells will make B plus 1 blocks for me in that row. Because there are B black cells, which make B plus 1 blocks. So the answer is gonna be m minus b over this this b plus 1, the scaling of it. The scaling of this value. So it's going to be m minus b over b plus 1. And this is going to be my final answer. Is it clear now or not? Nice pigeons. Yeah, good. I should start my career at drawing. Why b plus 1? Because there are b cells, and if you look at these intervals that we make, they also make an interval at the beginning and at the end as well. For example, if you have one block, you can distribute it to 2 parts. If you have 2 blocks, there will be 1 part here, 1 part here, 1 part here. So they will make b plus 1 blocks. Is it clear? I believe that this problem is even easier than problem C. And maybe even easier than B. Cool. Good. Good. I guess that now you guys have understood this. Can you check my Java code? Yeah, but I rather if you give me C++ codes, because most of the people have C++ codes. It's better to show everyone C++ code. But still, you can join our Telegram channel and put your code there and talk to the rest of the people. Guys, join our community there too. I mean, other than the channel, there are thousands of people right now, around 1,000 people there right now. You can join there too and talk about this with each other. We are the best community country. Yeah. Yeah. And guys, since too much time has been passed in these problems, I guess that we cannot go to the last problems. I will definitely discuss problem 86 minutes has passed. It's getting late. So I will definitely discuss E as well. But about F and G, I'm not sure. Maybe we will not discuss G. I think we should accept that we cannot get to G in the remaining time. But for F, possibly we can't get to F as well. Okay, I'll show you this solution. Again, guys, there's no justice on which one I'm showing. It's just luck. Let me show you this code. Also a C++ code as well. So basically by mathematics, also guys, let me tell you this as well. Also, I recently in my topic streams and solution discussions talked about something as well. That one could be used here too to give you some intuition on how to solve it. In here, again, we want to minimize the maximum. What did I tell you about when we want to minimize the maximum? If you have seen the previous streams. Exactly, as I so many times say, binary search works in this case. Why? Because it gives you a limit. And also in this problem, also binary search works as well. You could also binary search, and you can even see it in the tags as well. Binary search would also work on this problem. You could binary search first and then see if this many fits in the table or not. But this could also be solved with a simpler approach as well, without even binary search. But as a rule of thumb, as I said so many times recently, when you want to minimize the maximum or maximize the minimum, binary search always helps. Yeah, I try to hurry up. So let me first show you the code that you guys sent. It's very short but without indentions. It was better that if you had indents as well. But anyway, you have A, B, and N. The set is A by B, and the number of green cells is N. And it says that V is gonna be, this is scaling function. I mean, I assume that you all know that when you add denominator -1 to the numerator, it basically means that you want to calculate the scaling. So he calculates the scale of N over A. So he says that the worst row is gonna have V, the worst row is gonna have V green cells. And X is gonna be B minus V plus 1. Okay, so X is gonna be the number of blocks that we can make. It's gonna B minus V is the number of empty cells. This plus 1 means that how many blocks we can make. As I said, the number of blocks that we can make is gonna be the number of empty cells plus 1. V is the number of green cells. The number of empty cells is gonna be B minus V. And add 1, which is gonna be the number of blocks. And at the end, we have to divide by this number of blocks. And at the end, the answer is gonna be V plus X minus 1, the scaling of V over X. The answer is gonna be the scaling of V over X. So it's gonna be V plus X minus 1 over X. That is gonna be our answer. So it's basically that M minus B over B plus 1, that's I said here. So this way you could calculate it. Also, there's also this code that uses binary search. As I said, in this code you could also use binary search as well. He checks mid, and her calculation is like this. He will calculate that how many cells at most he can paint in green if he wants the answer to be at most mid. And if that number was greater than or equal to k, that is good, otherwise not bad. For each row, he says that the number of green cells I can make is going to be m over x plus 1 times x plus m modulo x plus 1. Basically, because you can paint the first x1 green and then 1 empty. Then x green, 1 empty, x green, 1 empty, x green, and 1 empty. And this way the number of green cells will be this, and if this value times the number of rows was greater than or equal to k, the check will be true. And he calculated it using a binary search. Is it completely clear? If it's clear, please put a plus or use this emoji again. It's 12:06 in India. Yeah, I know. It's taking so much time. 3:36. Where are you? SVSJ face off. In Korea. Oh, are these also Korean actors? Interesting. Yeah, my solution for this problem is off one. Yeah. It's you and your sister? Let me. Okay, maybe we should. Okay. Can you explain again the formula for binary search? Yes, the binary search says that basically if we want to have at most x consecutive green cells in each row, the answer is going to be m over x plus 1 times x plus m modulo x plus 1. Why? Because the main idea is that we put x green cells and 1 empty cell, then 1 x green cells and 1 empty cell, then x green cells and 1 empty cell, and so on. We will move on like this. This way, how many blocks do we have? M over x plus 1. Each of them have x green cells and 1 empty cell. So it will multiply by x. The last block, all of them will be green because the number of them is less than x, less than or equal to x. So plus m modulo x plus 1. That's all. 19 o'clock in Germany. Cool. We have someone from Germany as well. We see new countries. Yeah, I try to consider the smallest doubts as well. Okay, so let's move on to problem E. Thank you guys. Problem E. I haven't read this one before, so we should read it together and see. Let me first read it. Recently, Misha at the IT campus learned a new topic, the Euclidean algorithm. And guys, this problem might be the last problem that we will discuss today. So if you're waiting for FNG, probably you cannot do it today, but let me see. Editorial is not out yet too. Misha at the IT campus Newark camp learned a new topic, the Euclidean algorithm. He was somewhat surprised when he realized that A times B is equal to LCM of A and B times GCD of A and B. Okay, it might be interesting to consider their quotient. F of A and B is equal to LCM. Okay, so the ratio of LCM over GCD. For example, he took A equal to, okay. F of A and B is interesting. Since Misha has just started studying number theory, okay. So basically it means that one of the numbers, I mean, basically it means that if LCM over GCD was 1, it meant that they do not have any common factors. Sorry, not any common factors, sorry. That was, no. We want LCM over GCD to be a prime number. I got the problem. I want to think about it, but maybe it takes some time. Maybe it's better if I just tell you the solution based on the codes right away. But it looks like an interesting problem. Guys, basically it means that in all the factors, I think it believes that one number should be another number times a prime. Basically. One number should be equal to another number times a prime. F is easy. Okay, if you guys really want to talk about F as well, we can see. Let's see that how much time will be left. Let's see that how fast we can go talk about this. I think that one number should be the other number times the prime. That's it. Yeah, that's it. Okay, let me tell you the solution. So, okay, let me first explain the statement to you completely as well. Interesting ratio, it says that recently Misha at the IT campus camp learned a new topic, the Euclidean algorithm, and he got excited that A times B is equal to LCM times GCD, and now he's considering the ratio between LCM and GCD, LCM over GCD. And he says that two numbers A and B are interesting if A is less than B, and this value f of A and B is a prime number. You have to say that how many good pairs do we have? How many interesting pairs do we have? I say that if I have A and B, and I know that A is less than B, this only happens. Well, what is LCM of A and B over GCD of A and B? As the problem says, we want this to be a prime number. So when is it a prime number? It is a prime number if LCM of A and B is equal to GCD of A and B times P. Right? This is what we want. Times the prime number P. When does this happen? It means that just put P aside. Just put P aside. Consider the other prime factors like Q. The point is that for any other Q, the power of Q in both of the numbers must be the same. Because otherwise, these two numbers are not equal. LCM and GCD times P are not going to be equal. So for any other factors like Q, any other prime factors like Q, the power of Q must be the same in both of them. For P specifically, if here we have P to the power of I, in LCM you should have P to the power of I plus 1. So basically the only thing that LCM has in addition to GCD is one more power of P. The rest of the powers are the same. When the rest are the same, it means that both of the numbers, a and b, have the same power in all the numbers. Both a and b have the same power in all the numbers. Because GCD is the minimum power for each Q. GCD, the power in GCD shows that what is the minimum of these two. The power in LCM shows that what is the maximum of these two powers. When both of them are I, it means that both of the numbers have I. For P, it's I and I plus 1. So basically, it means that B must be equal to A times P. That's what it means. So the whole thing that we try to calculate is the number of pairs like A and B, A less than B, such that B is equal to some prime times A. That's all that this problem was. And how can we calculate that? We just find all the prime numbers, and after that we are gonna have a for on all the numbers from 1 to n, I think. Yes, the given n. We're gonna have a for to all the numbers from 1 to n, and we know that the sum of n over all test cases does not exceed to 10 to the power of 7. The sum does not exceed to 10 to the power of 7. So first I will tell you a solution that is a bit slower, and then we will optimize it. So what I can do is to have a for on all the numbers from 1 to n, and just do a binary search on the prime numbers and find the last prime number such that I times that prime number is less than or equal to n, and add that to our sum. So that's one solution that works, but it's of n log n, which is a bit slow. I will talk about how to optimize it as well. But so far we have an O of n log solution. We just keep all the prime numbers using a sieve and sieve of Eratosthenes, and after that we just, for each number, we have a binary search on all the prime numbers. We find the last prime number such that p times I will be less than or equal to n, and that is going to be our final answer. If it's clear, please put a plus or use this emoji. You will definitely reach, Shawnor, basically because you are really attending everything, and I see that you are putting effort. You will definitely reach it. To G we don't get to G, but to F it depends really. I mean, I try to do the best I can. I wanted to end it till 3 p.m. my time, which is gonna be in 13 minutes. But if you really need it, I'll see what I can do. It's gonna be hard, but if it's necessary, I will do that. I just answered your question, Muzammil. Okay. So that's all. And then after that, what I say is to optimize it further, I'll do this. Instead of binary searching, I do a two-pointer approach. I have all the prime numbers. Instead of binary searching, I know that for each I can have a pointer on prime numbers that what is the last prime that times this I is gonna be less than or equal to n. So if I know the previous pointer, I can only move it leftward as much as necessary. So as long as this prime number times I was not good, I will keep decreasing it. So this way, instead of doing binary search again with a two-pointer idea, I can easily find the last one. I can just keep it backward. Instead of each time binary searching, I will just move this pointer backward. So this way I can easily find out the latest prime number such that times I is going to be at most n. So this way I can solve it in O of n. Is this clear? That's all about it. I'm following Cheyenne. Cool. Yes. What if you pre-calculate all answers? I don't think that you can pre-calculate all the answers. I don't think that's possible. Okay, let me show you the code as well very quickly, because the code is also beautiful. What he does is to do a sieve, and sieve, guys, we if you know that in sieve you can also start j from I times I instead of 2i, and the time will be better, will get better than even nlog. So in sieve, instead of having the second for j from I to from 2 times I, you can start from I to I and just set that, okay, this number is not prime, instead of 2i, because the numbers that are a smaller number times I, they have been fixed by the previous primes before. So this is how you can keep the prime numbers, and then you can say that if sieve of I primes that push back I, and then he just keeps this 2 pointer. Basically what he does is this: he will pop back a prime number the first time that it is not giving us a number less than or equal to n when multiplied by I, and at the end he will see out the final answer. Is it clear? If there's any hard issue, let me know. Otherwise we can quickly move on to problem F as well. F, please. Okay, sure. If it's clear, please put a plus or use the emoji again, and then we will move on to problem F. Awesome. Awesome. I don't know, we can't get to G, unfortunately. I'm sorry. I wish that I could help with that as well, but I hope that I can help with F at least. Did pre-calc. Please put it in the Telegram group or in the comment section of Telegram channel and discuss it. Yes, sorry, anonymous. Okay, let's move on to problem F as well. Igor and Mountain. What does it say? I think because we said that it's so easy, I think the main challenge of this problem is a statement. Some programmers, but also physically robust individuals. Some practice swimming, some rowing, and some rock climbing. Master Igor is a prominent figure in the local rock climbing community. One day he went on a mountain hike to ascend one of the peaks. Follow established what to use his skills to climb strictly vertically. Igor found a rectangular vertical section of the mountain and mentally divided into n horizontal levels. He then split each level into m segments using vertical partitions. Upon inspecting these segments, Igor discovered convenient protrusions that can be grasped. Selected part of the mountain can be represented as an n by m rectangle with some cells containing holes. The sequence of distinct holes, a root is considered valid if the following conditions are satisfied. The first hole in the root is located on the very bottom level. Is not lower than the previous one. At least one hole is used on each level. Okay, so it's a table basically. At most 2 holes are used on each level. Okay, I got it. Igor can reach from the current hole to the next one if the distance between the centers of the corresponding sections does not exceed Igor's arm span. The distance between the centers of the corresponding sections. The number of different valid roots. So I'm not sure if each time he can put his hand on one of the holes or 2 holes at the same time. Oh, I see. You can always put his hand on only one hold, right? And thank you guys so much for the hearts. And for all the other emojis as well. So each time he can put his hand on one of the holds, right? Or two holds at the same time. It's funny reaction. I think it's faster if I see it here. Yes, distinct holds. Okay. Okay. I see it. I see. So we want to create a. I see. We want to create a route such that it goes to the topmost level. Okay. Isn't it DP? N and M are up to 2000 as well. It seems it can use a simple we can just start from the beginning and okay. I want to think about it, but probably I shouldn't. So let me tell you the solution. Let's take a look at one solution. KMJP solution. No, sorry. This one's better. Okay, he has a DP of 1 I and 0, 1 I and 1. Input and calc DP. Yes, okay. Okay, I found it, yeah. It's a DP with cross prefix sums. Because from each row there's a interval of the cells that can work and you just need to sum them up. That's it, right? That's just it. You have the DPs and from each row you have to sum up an interval. Yes, DP with prefix sums. Yeah, we just do DP with prefix sums. Let me explain to you the solution, the statement first. Okay, problem E, Igor and Mountain, it basically says that we want to climb this rock and in each row there are 2 places that we can put our hands on. And we want to go upward. Starting from the first, we want to start at the first row and at the last row. And we can go from one of these holds, one of these hashtags to another one of these hashtags if the distance between them is at most d. And the distance is the Euclidean distance. You have to say that how many valid routes do we have from the first row to the last row. Each of these holds must be at least each of these holds must let me see. Okay, each of these holds must not be lower than the previous hold. So they must be in increasing order, considering their heights, their level. So the idea, guys, the main idea is using a DP. Starting from each hold, I want to find out that how many ways do I have to start from this hold and move to the last row. And the point is that because N and M are both up to 2000, N and M are both up to 2000. So if I have a 4 on all the rows, from each row, from this hold, I can go to an interval in that row. There's an interval of the cells that their distance to this one is less than or equal to D. The rest have distance greater than D. So basically, because I have to add the sum of the DPs that I have in here to here, if a cell did not have a hold, the answer is 0 in that cell. Otherwise, I put its DP in that cell. I just need to find out what is the sum of the DPs in here, which is a simple prefix sums. I calculate the prefix sum and just subtract this from this. So that's a simple prefix sum. The only remaining point is that because each row has at most 2 holds, at the end, I should also consider the case that my first move is gonna be to a hold in the same row. That's why I define 2 DPs, DP0 and DP1. DP0 is the case if I go to the next row afterwards. Go to above rows. DP1 means that we can also remain in the first row, in the same row. We can move to the upper rows or stay in the same row. So to the DP1 of these, we should also add the DP0 of the other one as well. Because each one of these could go to the other one. From DP1 of each one of them, we could also go to DP0 of the other one. So DP1 of each one of them is going to be the sum of DP0 of both of them if their distance is less than or equal to D. So basically the main point is that if from this hold I want to go to the above holds, I should first fix that to in which row is that, and in that row I should go to an interval of that row. Only an interval of the cells in that row have distance less than or equal to D to me. I will find that interval, and once I found it, I use a simple prefix sums and I find the answer. And then after that, when I sum this up for all the rows, I will also consider the case where my first move is going to be in the same row. In that case, I will also need to add DP0 of the other cell in the same row if its distance is at most D to DP1 of myself. So my DP1 will be the sum of DP0 of both if the distance is going to be less than or equal to D. If that does not exist or the distance is more than D, it's going to remain as DP0. And these prefix sums are going to be also on DP1s. So that's all about this problem. Is this clear? We did it very quickly. I wasn't expecting that we can do it. Isn't G possible? Just a hint will do. Let me see what G is. Is F completely clear? If you guys have any issues with problem F, let me know. So I guess that everything is clear, and thank you guys so much. Let me give you a heart as well for all your supports. Okay, let's take a look at problem G as well. Let's see what it is first. What is it saying? Renowned rower, so he covers parts of his journey from home to the campus by kayaking along the river. Assume that Goya's his current power is X, then with one paddle stroke. The problems today were beautiful so far. I like them. But such a maneuver is quite challenging, and after each turn his power decreases by 1. The power cannot. Okay, so he has some power, and if the power is X, one paddle moves exactly X meters. The power can never become 0. Okay. Reach point S from point 0 without leaving the segment 0 to S and while preserving as much power as possible. Help him, given the value of S and his initial power K, determine the maximum possible power he can have upon reaching S. So his power is initially K, and he will keep going each time by reversing. His power decreases by 1, and he wants to get to S with maximum possible power. Let's take a look at this one as well. And we start at point 0. Let me take a look at this one as well. This one also looked like a beautiful problem. If S modulo K was 0, definitely the answer is K. If S greater than K times K, the answer is maximum of Y and K minus 2. Okay, it gets a bit mathematically now. Okay. Okay, it makes sense, I think. S is up to 10 to the power of 9, so he limits it up to 10 to the power of 6, and then he will define a dp. Cool. And the sum of k over all test cases is at most 2000. And the time limit is 3 seconds, so he can do a k by n solution now. NDP is equal to dp of I minus k plus, or NDP of I minus k okay, so it will move forward k times. Okay, I will tell you the solution of problem G as well. I think I understood it. I think. Let me tell you this. The problem glib and boating problem G, it says that basically some person glib has a boat. He's at point 0 at the beginning. He wants to go to point S. At the beginning his power is K. He can move forward each time by K. And he can also turn back each time, and each time that he will turn around, his power decreases by 1. And he cannot just turn around twice in a row. And you have to say that he wants to go from 0 to S without leaving this segment of 0 to S. You have to say that what is the minimum number of steps, not minimum number of steps, but you have to say that what is the maximum remaining power that he can have when getting to point S, starting from 0. And K is up to 1000, S is up to 10 to the power of 9, K is less than or equal to S. Also, and another important thing is that the sum of K over all test cases does not exceed 2000. Let me tell you something that helps you. I mean, basically, it's the whole solution. Guys, in here, first of all, I say that if S modulo K is 0, the answer is definitely K. We don't need to do anything. We just go forward by K. That's very easy to say. But the main idea is this. You can show that if S is greater than or equal to K times K, the answer is going to be K minus 2. Maximum of K minus 2 and 1, basically. Because if K is less than 3, if K is, for example, 2 or 1, 1 is not possible because 1 would be here. But if K is 2, still you will give 1. It's going to be maximum of K minus 2 and 1 because your power always remains 1. So why is that true? Because you can easily see that you can construct it. Because you need at least K jumps in this case. You have at least K jumps. So you can see that what is your if you make all the jumps by size K, you will land somewhere after S. For example, you will have some offsets. You will go by X additional cells that you should have not gone. What you could do instead of that, after you can see that you can say that x is less than k. So what you could do is to, instead of doing it these many times, you could change some of this to k minus 2. At some point you should go back instead and then continue going by k minus 2, and by doing this you can subtract this value and basically land at s. Okay, so basically this is something that is gonna help you. Thank you guys, thank you. So this is the main thing that is gonna help you. So basically if s is gonna be greater than k by k, think more about these parts. So this is what helps you to solve this problem. If s is greater than or equal to k times k, the answer is at least k minus 2. Otherwise, if it's not, you will do a dp. Otherwise, if it's not, you will do a dp. And how is that dp? Well, the point is that the sigma k is at most 2000. And also, n now is at most, or s now at most is k squared, which is at most 10 to the 6, because k each time is at most 1000. So what you do is this. You have at most k terms. Initially your power is k, then k minus 1, then k minus 2, and so on. So you will have a Boolean array. First of all, you will go forward and update everything from cell k before it. And then you create one term, and then you update everything from k minus 1 after, new power after it. And then again another term, update everything from anything before it, and so on. So k times you will move forward and backward and update values, the cells that now you can reach. And the first time that you can reach position s, you're done and you have the answer. If you want to see the code as well, the code is here. Basically this is what it does. If s was greater than k squared, this is something that, guys, you should think about and prove it. Just do not, it's good to also learn that why is it like that. Just make it more precise. And then after that, when you want to calculate this dp, you have k times you do it. Each time you see that he's decreasing power by 1. He will keep moving, each time updating the values and then turning around, and then doing it in the other side and again turning around. And he will see that what is the first time that he will get to position s, and he will see out that k and will return. That's all about this problem. If it's clear what I'm saying, again, put a plus or use this emoji. If it's not, also let me know. I think that this helps you to solve problem G as well. I mean, it's basically almost done now. So we're basically going from one end to another. Yes, we go from 0 to s. Okay, awesome. Awesome. Okay, I have to go quickly now, but I'm gonna see you guys very soon in topic streams, hopefully, so that values are equal. Yeah, we want to go from 0 to s so that at the end our power will be maximum possible value. Thank you, Biswaran John. I hope that I pronounced it correctly. Sure. Thank you guys very much. It was great to have you here again, and see you guys soon. Well, I basically just tell you an outline of the solution. I was just saying that. I mean, that's something you can watch the video, that part of the video again if you want. But basically, the main idea was that you can show that if s modulo k is 0, definitely the answer is 0. The answer is k. Your power does not need to decrease. If it's not, you can show that if s is greater than k squared, the answer is at least k minus 2. Because the idea is that you have at least k jumps, so you can just change some of them to k minus 2 to have the answer at this k minus 2. Otherwise, you will do a dp, and you will keep going forward and backward and calculate them. Okay, guys. Awesome. Yes, that is very good. Solving 3 problems in the first contest is very good. Thank you guys again for joining, and see you guys soon. So goodbye for now.